Here we go. So, it says to factor. It says to factor. It says to factor. It doesn't say to multiply. It says to factor. So make sure you factor, which kind of like divide. The opposite of multiply. You ready? Okay, so now, remember when we factored, we first looked to see, can we divide out a number? Can we find a GCF, a greatest common factor, between each of these numbers? All right, well, what's the biggest number you could divide? 4. So I could divide 4. Now, do they have a common variable? Do they both have x or another letter? No, they don't. So that's the only factor that we have between the two numbers. So I'm going to write 4 here, and then I have to complete the expression. Okay, so to complete this expression, I need to write terms in here. So, first thing I'm going to do is do 16 divided by 4, which is 4. But then I also have to include x. Okay, and then 20 divided by 4, which is positive 5. And there's my complete expression, factored out. Done. Okay, next part. Number 9. So here we go. We're going to find the GCF. So we got to look at the 12, we got to look at the 20. What number can you divide into both? Thanks, Lillian. It's number 4. Here we go. Divide 4. Now we also got to look at the variables. What variables do we have in common? Well, we have x to the 4th, x to the 6th. So how many do they share? Go ahead, Sarah.
4.
4. So 4 x's. All right, so that's our GCF. Here we go.
4x.
4x to the 4th times, let's complete the expression, everyone. All right.
3.
Hey, I'm running the video, not you. Okay? 12 divided by 4 is 3. Then if I have 4 here and 4 here, I don't need any more, so I'm done. That's right, Lillian. Put your hand up. Okay, so 20 divided by 4, 5. If I have 6 here and 4 here, that means I have 2 that I need to complete the expression. But there's a problem. What's the problem? So anybody?
Huh?
What's the problem? Go ahead, Jack. I just told you.
It's supposed to be standard.
Standard form. Thank you. These need to be in the right order. Highest exponent goes first. All right. So here we go. 4x to the 4th. No one's looking at me like I'm crazy, but that's okay. All right. So make sure, everyone, you put your highest exponent first. Okay. Then we know that we are. Okay. Number 10. Same steps. Remember, you got to look for the GCF. And if there is no GCF, then we have to do the box. So let's see if there's a GCF first. So, first, can I divide a number to each one? Anybody?
6. Right here, 6.
6. All right. That's the biggest one that we can divide. You might be sitting there thinking for a while. Take out your calculator, start dividing. Start picking numbers and find the biggest one that will divide. The greatest, not the smallest. Because some of you guys are going to say 2.
No.
But 2 is not the greatest. Okay? So, divide 6. Divide 6. Okay, now what's the greatest common factor for the x? How many?
1.
1. So 1x. Okay, now let's do the next step. That's our common factor, or our GCF. Okay, 48 divided 6? 8. 4 here, 1 here. So that means we have x cubed there. Then bring down the sign. Don't forget this is minus, or negative. 24 divided by 6 is 4. We have x to the 3rd and x. So we have how many x's now? 2, or x squared. That's right. Okay, now if this is 6x divided by itself, it's the same number. It's always going to be
1.
1. Okay, where 6 divided by 6 is 1. X divided by x is 1. All right, number 11. He's saying 1 because we have 1 championship. And then this year we're going to have, guess what, Nars? 2 championships. All right, next problem.
Wait, you didn't stop it.
See? 1 and 1, Nars, just for you. All right, so here we go. Do we have a GCF?
3. 3x. You're gonna go so
There's a 3. Yes, it divides into all of them.
Wow, I'm correct.
And not just 1x,
3x.
but how many x's divided into 3? Right. 3. X what? Cubed. Not just 3x. 3x cubed. Okay? That's for you, Arnold. Cubed. Okay, 21 divided by 3. 7. Okay? X to the 4th minus x to the 3.
X.
Oops, did I forget something? Come on, you gotta check my work. When am I supposed to put first?
Then parentheses.
Yeah. gotta put the factor. Don't forget everybody. Okay, I'm testing you. Okay, I want you to finish the rest of this problem. Pause the video, do it on your own, and then bring it back and see if you're right. Okay, so here we are. Again, I started early before, so 21 divided by 3, that's gonna give us 7. We have x 4 here and 3 here, just 1x. Okay, bring down the sign. 27 divided by 3, 9. If we have 5 there, 3 here, we need 2. Remember, we're trying to complete the expression. X to the 3 times x to the 2 is x to the 5. That's why we're subtracting and taking away there, okay? Thank you, Lena, for correcting me. All right, so 15 divided by 3 is 5. And if I have x to the 3 here,
5x.
x to the 3 here, do I need any more x?
No.
No. So let me bring it a little closer, a little tighter, so it looks a little nicer. And then circle my answer. And then I'm dropping the marker.
That's what I got.
Okay, you'll notice that there's 2 number 12s. So, and then, this is the first number 12. Okay. So again, see first, can you divide a number into each term? Here, yes, I can divide a number. That's gonna be 8. So 8 here, 8 here. Okay. Now how about the x variable? Okay. What do they have in common? They both have at least 1x. Okay, do they both have a y variable? Yes, they both have at least 1y. Another way to look at this, if I take these x's, and there are 3 of them, right? So I have 3 x's, and then here I have just 1x. How many do they have in common? Well, they both just have 1. Same thing with the y. I have 2 here, 1 here, they both have 1. So that's why I put 1y there. Okay, I want you to finish the rest, and then turn the video back on to see the answer. Okay, so again, I divided the GCF, I divided each term by the GCF. 16 divided by 8 is 2, 24 divided by 8 is 3. I have 3 here, 1x here, so 2x is here, 2y's here, 1y here, so that makes 1. Or basically what I'm doing is 3 minus 1, 2 minus 1, that gives us this variable, or this term. And then here, it's just x over x and y over y, which is just 1, so I don't need to include that here in this part. Okay? All right, we've officially encountered our first problem where we can't find a GCF. If I look at b squared and 11b and 26, first of all, 1, 11, and 26, is there a common factor? There's nothing you can divide. Do they all share at least one variable? No, they don't. So this is where you have to do the box. Okay, or you're going to have to factor a quadratic. Okay, do our box. Remember, the first number goes in the first box. The last number goes in the last box. Okay, and then we say the first number times the last number goes here. So basically 1 times 26, which is 26. Okay, and then we have to find all the numbers that multiply to 26. Because when we find that combination, we want them to add to the middle number. Okay, so bear with me. Here we go. 1 times, well, the number itself, 26. 2 times 13. Okay, 3 times, 4 times, 5 times. Nothing else goes into 26. That's it, just those 2 combinations. So now I have to say to myself, with 1 and 26, can I either add those numbers or subtract them to get a negative 11? No, I can't. Can I? Because 26 minus 1, that's 25, not 11. And 1 plus 26, that's 27, not 11. Now about 2 and 13? Well, 2 plus 13 is 15, that doesn't work. But how about 13 minus 2? That's 11, so that'll work. So we're going to put those 2 numbers here. And remember, we want them to add to a negative 11b, so make sure you put a b. Okay, but now I need them to add to negative 11.
Negative 13?
Are you sure?
Yeah.
Are you sure it's negative 13?
Yeah, because it's
What if I
bigger
put
than-
a negative 2 here? What happens?
So it will be positive.
Right.
Positive.
13 minus 2 is positive 11. So like Lena said, we need to make 13 negative. Okay, now you need to find GCF for one row or one column. So let's maybe start here. Doesn't matter where you start. I could even start here if I wanted to. Matter of fact, let's start here. Okay? Looking at 2 and 26. What's the GCF? Biggest number? 2. That's the biggest number you can divide. And then once I find GCF for one of them, then everything kind of falls into place. 2 times what is 2b. b. Okay, b times what is b squared? Also b. And then b times what is negative 13b? Minus 13. And there's our factors. So you're going to take the one on the left, b and 2, that becomes b plus 2, times b minus 13. Boom, you're done. And remember, we call each of these parentheses, or each binomial, is called a factor. So this is called a factor. Okay, that's important on that last page of the test. Okay, all right.